Hello everyone and welcome to Roadmap. So today's topic is acid, bases and salts part 1, and if you like the video don't forget to click on thumbs up button below. You can also subscribe for more video updates. The topics to be covered are introduction, chemical properties of acids and bases, reaction of acids and bases with metals, how metal carbonates and hydrogen carbonates reacts with acids, reaction of acids and bases with each other, reaction of metallic oxide with acids, commonness among acids and bases, importance of pH, then more about salts, chemicals from common salt, and are crystals of salts really dry? So I've already covered with the part 1. You can check the video and then come to part 2 so that you will be able to link the concepts in more better way and you'll have a more better conceptual understanding. So coming to the question, how strong are acid or base solution? We know how acid and base react indicators can be used to distinguish between an acid and base. We have also learnt in our previous section about dilution and decrease in concentration of H plus or OH minus ions in solutions. Can we quantitatively find the amount of these ions present in a solution? Can we judge how strong a given acid or base is? We can do this by making use of universal indicator, which is a mixture of several indicators. The universal indicators show different colors at different concentrations of hydrogen ions in a solution. A scale for measuring hydrogen ion concentration in a solution called as the pH scale has been developed. The P in pH stands for potence in German, meaning power. On the pH scale, we can measure pH generally from very acidic to very alkaline, that is from 0 very acidic to very alkaline 14. pH should be thought of simply as a number which indicates the acidic or basic nature of a solution. Higher the H plus ion concentration, lower is the pH value. The pH of the neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution, and as the pH value increases from 7 to 14, it represents an increase in OH minus ion concentration in the solution, that is increase in the strength of alkali. So paper impregnated with the universal indicator is used for measuring pH. So from the figure you can see that 0 to 7 acidic nature is increasing, increase in H plus ion concentration, and basic nature is increasing from 7 to 14, decrease in H minus ion concentration, H plus ion concentration, and the 7 is where it is neutral. So this is how strong our acid or bases in the solutions we can make out. Now coming to the importance of pH in our everyday life. Now, our body works within the pH range of 7 to 7.8. Living organisms can survive only in the narrow range of pH change. When a pH change of rainwater is less than 5.6, it is called acid rain. And when the acid rain flows into the rivers, it lowers the pH of the river water. So the survival of aquatic life is in such rivers becomes difficult. So are plants and animals pH sensitive? This is the answer to that. Now what is the pH of soil in your backyard? Now plants require a specific pH range for their healthy growth. To find out the pH required for the healthy growth of plant, you can collect the soil from various places and check the pH in manner. Like it has got some procedure. Now put about 2 grams of soil in a test tube and add 5 ml of water to it. Shake the contents of test tube, filter the contents and collect the filtrate in test tube. Now check the pH of this filtrate with the help of universal indicator paper. Now what can you conclude about the ideal soil pH for the growth of plants in your region? So this is a procedure to make out the soil in your backyard. Then coming to the pH in our digestive system. Now it is very interesting to note that our stomach produces hydrochloric acid. It helps in digestion of food without harming the stomach. During indigestion, the stomach produces too much acid and it causes pain and irritation. To get rid of this pain, people use bases called antacids. Now one such remedy must have been suggested by you in the beginning of the chapter. Now these antacids neutralize the excess acid. Magnesium hydroxide, milk of magnesia, a mild base, is often used for the purpose. Now coming to the pH change as cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel, made up of calcium phosphate, is the hardest substance in our body, and it does not dissolve in water but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produces acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food. Using toothpaste, which are generally basic for cleaning the teeth, can neutralize the excess acid and prevent tooth decay. Now coming to the self-defense by animals and plants through chemical warfare. Now, have you ever been stung by a honeybee? Bee sting leaves an acid which causes pain and irritation. Now, use of a mild base like baking soda on the stung area gives relief. Stinging hair of nettle leaves inject methanic acid, causing burning pain. Now, coming to the more about salts. Now, consider an activity, family of salts. Now, write the names of the various salts such as potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate, and ammonium chloride. Write the formulas of them and identify the acids and bases from which the above salts may be obtained. Now, coming to the pH of salts. Collect the salt samples like sodium chloride, potassium nitrate, aluminum chloride, zinc sulfate, copper sulfate, sodium acetate, sodium carbonate, and sodium hydrogen carbonate. Check their solubility in water. Now use distilled water for this purpose and check the action of solutions on litmus and find the pH using a pH paper. Which of the salts are acidic bases, basic or neutral? Now identify the acid or base used to form the salts. Now, salts of a strong acid and strong base are neutral with pH 7, and salts of a strong acid and weak base are acidic with pH value less than 7, and those of a strong base and weak acid are basic in nature with pH value more than 7. Now, coming to the chemicals from salt. Now, by now you have learned that the salt formed by a combination of hydrochloric acid and sodium hydroxide solution is sodium chloride. Now, this is a salt that you use in food. You must have observed in the activity that it is a neutral salt. Now, seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salt are found in several parts of the world. Now, these large crystals are often brown due to the impurities. This is called as rock salts. Beds of rock salt were formed when seas of bygone ages dried up, and rock salt is mined like coal. Now, you must have learnt about Mahatma Gandhi's Dandi March. Did you know that sodium chloride was such an important symbol in our struggle for freedom? Common salt, a raw material for chemicals. Now, the common salt obtained is an important raw material for various materials of daily use such as sodium hydroxide, baking soda, washing soda, bleaching soda, and many more. Coming to the sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide, and this process is called chlor-alkali process because of the products form chlor for chlorine and alkali for sodium hydroxide. Chlorine gas is given off at the anode and hydrogen gas at cathode. So this is about the sodium hydroxide. Coming to the bleaching powder. Now, chlorine is produced during the electrolysis of aqueous sodium chloride, and the chlorine gas is used for manufacture of bleaching powder. It is produced by the action of chlorine on dry slaked lime. Bleaching powder, though the actual composition is quite complex. Now, uses of bleaching powder. For bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry. As an oxidizing agent in many chemical industry, and also for disinfecting drinking water to make it free of germs. Now, coming to the baking soda. Soda commonly used in kitchen for making tasty crispy pakoras is baking sodas, and sometimes it is added for faster cooking. The chemical name is sodium hydrogen carbonate, and it is produced using sodium chloride as one of the raw materials. Now, uses of sodium hydrogen hydrogen carbonate for making baking powder, which is a mixture of baking soda and a mild edible acid like the tartaric acid. When baking powder is heated or mixed in water, carbon dioxide produced during the reaction causes bread or cake to rise, making them soft and spongy. So, sodium hydrogen carbonate is an ingredient in antacids. Being alkaline, it neutralizes excess acid in stomach and provides relief. It is also used in soda acid fire extinguishers. Now coming to the washing soda. Now it is obtained from sodium chloride, and sodium carbonate can be obtained by heating baking soda. So recrystallization of sodium carbonate gives washing soda, and it is a basic salt. Now the uses of washing soda. Sodium carbonate is used in glass, soap, paper industries. It is used in manufacture of sodium compounds like the borax, and sodium carbonates can be used as a cleaning agent for domestic purposes. It is also used for removing permanent hardness of water. Now, are crystals of salts really dry? Now, consider the activity. Heat a few crystals of copper sulfate in a dry boiling tube. What is the color of the copper sulfate after heating? Do you notice some water droplets in the boiling tube? Where have these come from? Add 2 to 3 drops of water on this sample of copper sulfate obtained after heating. What do you observe? Is the color of copper sulfate restored? Copper sulfate crystals, which seem to be dry, contain water crystallization. When we heat the crystals, the water is removed and salt turns white. If you moisten the crystals again with water, you will find that color of crystals reappears. Now, water of crystallization is the fixed number of water molecules present in one formula unit of a salt. Now, one other salt which possesses water of crystallization is gypsum. It has two water molecules as water of crystallization. So, coming to the plaster of Paris, on hitting gypsum at 373 Kelvin, it loses water molecule and becomes calcium sulfate hemihydrate. And this is called as plaster of Paris, the substance which doctors use as plaster for supporting fractured bones in the right position. Plaster of Paris is a white powder, and on mixing with water, it changes to gypsum, once again giving hard solid mass. So this is about the plaster of Paris. Now this completes the chapter of acid, bases and salts. I hope that you are enjoying the video. Stay tuned for more lessons to come. If you have any doubts, feel free to ask in the comment section below. Thank you for watching.